Hey guys, welcome back to the channel. I have another ECM repair, this time in a 1999 Dodge Ram 3500 5.9 diesel. This was sent to me by Orwix. Let me just make sure I said the name good. Orwixburg Service in Pennsylvania. Francis, this is your computer. I have started test and I have everything ready to go. I'm going to start a screen recording so I can explain a little more of what I have connected in here and the test that I'm going to perform. I have the Phoenix Max ready to go. I'm going to be using just this meter for, to check the fiber reference. So I probably better if I move this way so you guys will see when I turn the computer on if that is indeed good. So I'm going to set you guys in here, get you to focus a little bit on what I'm going to do on the computer, and then we can talk about uh, everything. All right, so customer concern, no communication with the ECM, and then also that is damaging the fuel pump control module, which is built like into the injection pump. So this is a Cummins computer. It's a 15-pin computer. So let me just start 1 second the screen recording. All right, guys, I got the screen recording ready to go. Not sure if I want to be in the camera this time or just like this. I hope that you guys can see the meter. You're going to see probably just my hands in there. I will like or try to move the scanner so you guys can see a little bit. All right, so let me just explain what I have here because things that I want to make some of the customers understand is that yes, when you work in so many different brands, it's impossible to have the harness for every single computer you're going to send. So yes, it takes a little time for me to get the connections ready, make sure I got everything connected properly, and then perform my test. I'm using the universal test platform, break a decade box just to supply a resistance for the coolant temperature sensor so we can see, make sure the computer reads or not. Not using my power supply. One of my power supplies, I'm using the big one because this is a diesel ECM, so I want to make sure that I got enough use for when this is powered up. So almost all the information that I have here is coming from Identifix and or Pro Demand. So as you can see, yeah, this is from Identifix. This is a connector on the harness side. So this is, I also put a mark pin 1 and pin 50. How do I find out which one is pin 1 and pin 50 when you're working on a computer? Let's say like in my case, I don't have the harness. It's pretty easy on the harness because you can see, check with the multimeter and see which ones are grounds or not. But it's not so hard or so different in here. I'm going over to the wire diagram. Let me actually go over here like that I can deselect everything and we can go slowly. So if we see the grounds, okay, on this 50 pin connector, pins 49 and 30 are ground. So yes, you go over here, you put in continuity and you find 49. It can be only two corners, right? So if we go back to that connector, we can see the 49 and 30 is either here or here. Well, it can also be, if depends how sideways is this, right? So it can be the other way, but it's going to be in a corner. So pin 49, it has to be in one of the corners. And then 30 should be 3 pins up, right? So you got the second one, 49, well, in this case, it's right here. And then the third one, 1, 2, 3, is pin 30, and that's how I found it. And then I know now this is pin 50, and that's pin 1. Uh, this is the pinouts for the computer. What I have connected in here, I got pin 3 is 5-volt reference. Pin 4 is sensor ground, so I know that I have or not a good 5 volts for the computer to provide for the sensors. Pin 5 is ignition. It's only going to be an ignition or a start, so that's an ignition power supply. Going down, we got another 5 volt and pin 10 and another sensor ground on pin 11 that or I will do that check later. Another test that I'm doing, because this is part of what their concern is, they said that they lose communication with the fuel injector pump module, and that is the diagnostics, or the car will communicate to the computer, and the computer communicates directly to the fuel pump module. I'm going to show you that in a second on the wire diagram. But we have pin 13 and pin 23. If I go a little faster, we can see it's dattling positive and dattling negative for the fuel injector pump. All right, so um, going down, what else we have? We got, okay, 30 is a ground. We have then the transmission to go into the DLC. This will go pin 38 will go into the DLC pin 7, and pin 39 will go into the DLC pin 6. And again, I will show you that in a second. And then we have our powers. This is battery positive, as it says in here, on 48 and 50, and then another ground on 49. So this is what I like to connect in a computer like this, so I can check whether or not we have communication. Concerns that I immediately feel, because looking at the diagram, let me go back to here and deselect the grounds. Well, first, let's go and step by step. Communications. We have again pins 13 and 23. I'm going to mark them so we can go and see that that goes straight to the fuel pump control module. So this is built on the top of the fuel pump. This is a rotary pump, and you will see, for those that are not that familiar, it's like on the front of the engine on the driver's side. Has a little, you have to remove the intake and some other like part of the intake manifold to get that pump out, just get the lines out. It's just, I mean, it's a time consuming, but it's definitely doable, obviously. But yeah, so their concern is this pump gets burned. I'm like, well, okay, looking at these, I'm going to double check, make sure the computer has communication to the fuel pump on those 13 and 23. But then looking at also, which I have here, this is the pinout for that fuel pump module. This is, as you can see, from Protoman with the VIN number. This is the VIN number of the vehicle, 46909, the last digits. But yeah, so we have that here. We have powers and grounds, and then fuel pump relay output. Okay, this pin 7 is the one I want to see where it's coming from. Is the computer in charge or what else? So I'm going to use the web just because it's a lot bigger. But if I go over to that fuel, what was it, pin 7? Yeah, if I follow that pin 7, we can see that it's actually not a built into the ECM relay control. Well, the controller is on the ECM, but it's an external relay. So we will have, okay, terminal 87, and then we have a constant power coming from here that says that it's hot all the time. So we got a constant power. As soon as this relay is energized, it's going to be a power going directly to that pump. And this pump, if we see right here, if we follow these grounds, it has a constant ground. So as long as it's power in here, this pump will be on all the time because it's directly attached to the battery, let's say through the relay. Obviously, the relay is in control. But let's say if we have a problem, well, okay, now let's take a look at the control side, right? This is the contactor part, and this is the um, control side. All right, so if we follow pin 85, that is a ground. So this relay is power side switch control from the ECM. All right, so I'm going to mark now this pin 86, which is coming from the computer ECM, on pin 36. So that pin 36, I have it here. Hopefully you guys can see that. I got that pin 36 in here on a test light. So I'm going to move this a little bit of the way so you guys will be able to see that. So I got a test light and then just supplying ground as is in there, right? So you guys can see that from there. Yeah, I think so. Yeah, I think it's perfect. All right. So that fuel pump relay should not be on until the computer commands it on. Not sure if it's a prime because I'm not that familiar with this system. I don't think this will need to be prime because this is the high pressure pump. This pump or this system has a transfer pump. That's the one you will need to um, let's say, use it for priming, but this pump should be free of air and should be power pressurized, let's say, unless the transfer pump or any lines are open and then it's leaking, an injector line is leaking or something like that, and then you can get it on the system. But so this is as far as tier of operation I have read, this pump should not be on until you want to start the vehicle, right? Okay, so um, what else do I want to show in here? I have again pin 23 and pin 13. I had two channels, uh, red and blue from my picoscope that I have ready to go right here. So this is the picoscope ready to go. I already set up the readings so we can see something going on or not. So I put, well, the way my setup is channel A plus minus 5 volt, the same on both because that's the signal. 200 microseconds per division. I click in here. Don't click on the plus or minus because all you will do is change the time. And this is for all Pico 7 automotive or not automotive. It's the same software, let's say. So if I click in here, I can then now change the sample rate. I bumped the sample rate up to 2 mega sample millions. Oh yeah, mega samples per division, or no, no, this is not per division. This is 2 mega samples per screen or recording. Um, you can change the sample rate, you can change the buffer. This is where you want to do that. After I did that, I went over to the DSP and I put a filter on both channels of 2 megahertz. This will, because this is a fast signal, and then it's going to look complete with these settings. All right, so that's all I have in here. Going back to one diagrams, let me see what else I want to share. This is how I find out the communication from the computer to the scanner. So this is the data link connector. You're not going to be able to see, hopefully. Look for these, I hate this PDF that shit takes my hand. You see how I have now a black cursor in here? As soon as I go into the document, that arrow disappears. So look at right here. I got my, on the left side, kind of like in the middle of the screen, I have that black arrow. I'm going to move it in. So these pins 6 and 7 are going, like I said, on pin 39 and pin 38 on the ECM. So that's how I know how the computer communicates. All right, this is pretty much what I want to share. So I got everything ready to go. Let's power up the computer. Okay, so we got 5 volts, as you can see right there. This is no good. As we can see, we got a constant power on the fuel pump relay. That will cook that fuel pump module and the fuel pump because it's constantly on, constantly on, and constantly on. So yeah, that's why these pumps are being burned. Communication from the computer to the fuel pump module, it seems to be okay. And this is what I'm checking in here. So this is again the data link communication between the PCM, or sorry, not PCM, ECM to the fuel pump module. So these two lines are good. I don't see anything wrong with that. That communication, I can even change the speed a little bit so we can see more detail. But as you can see, it's a nice communication. Let me stop that so we can measure a little bit of these signals to see what the amplitudes are. Uh, if I move the cursor to the place that I want. So we're going to put in the red channel, two cursors, and two cursors on the on the blue channel as well, which is going to be almost the same on one spot, right? The middle where they meet. It looks like they're completely a mirror of each other. It's almost like a COM bus, right? So we're having 2.5 to 3.8, so that's like 1.3, and then we had 2.5 to 1.14, almost like a CAN bus. Uh, let's see what the speed of the communication is. Mm, we can probably just set up a cursor here. I'm probably going to have to zoom a little more. Let me just zoom a little more. Why is that changing? Oh, because not running it. That will be good to run it, right? And as you can see, as soon as I'm doing that, the sample rate goes up. Like right now, I'm in 1.25 gigasamples because this is a fast signal. All right, so let's move this cursor here. I want to see what the speed of communication is, and we have 4 microseconds. So yeah, this is like almost like a CAN bus speed. So yeah, that is healthy. Healthy communication. I don't see nothing wrong with this. I can change the speed again to 200 microseconds. There is no acknowledgement being or anything like that because obviously it's not connected to the field pump module, but it is a fast communication. All right, so again, nothing wrong with that. So let me just bring this down. What else do I want to check? Oh, let's put the scanner. Might want to hold the phone so you guys can see this, because otherwise you're going to be facing too far away. So let's try first an auto scan. I know it's not going to work. This is a 1998, so most likely you need to have the entire vehicle connected in order to read the beam from the cluster or other modules, not just from the ECM. But let's try it, because this is how, I want to share the information with you all so it's complete. So if you're doing a test in your vehicle and you're not having communication, then you understand why. If you're going straight like me, straight to the ECM and you're removing the vehicle, because you can do this in the car, you can remove the pins 38 and 39 and just connect direct to here with your scanner, and that will work as long as you have the same pins going into a data link connector like this. It will work, right? uh, you will just need to provide, if you're doing something like this, you will need to provide a ground on pin 4 and 5 and a constant power on pin 16, and then pin 7 and pin 6 connected to pin 38 and pin 39, and that computer will talk. And I'm going to prove that because that's exactly what I'm doing here. So I'm going to skip this, click OK, enter the VIN number, and we have the VIN number in here. So it's, let me just put the VIN, yeah, because I don't want to stop the, so it's 1B7, 1B7 MF 3364 WJ 24, yeah, 246909. Yes, I'm typing. I'm typing in my keyboard on my computer. All right, guys. So here we go again. 1B7 MF 3364 WJ 3364 WJ 246909. That's better, right? That's funny. Too many things at the same time, right? But yeah, so let's establish communication. The reason I'm doing this, I want to see if I've changed the temperature. Let's see if we can read the battery voltage and see if we can read temperature. This is just a normal reading. Make sure that nothing else is connected when you're doing this communication. All right, let's see. Vehicle identification, blah, 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 year, Ram truck. Attention, the vehicle information is important. It's necessary to report this vehicle information to us if there is a problem during the test. Connector might be required. Yeah, well, I don't think with what I have, I need to have any other connectors. All right, so let's enter the PCM. All right, so we are here. Can we read full codes? Yes, we can. That's good. All right, let's go over to data stream and just pick up engine battery voltage and coolant temperature. All right, so looks like we are indeed reading. Let's change. So I'm going to change the values here. All right, so with this, and let's take a look at that temperature. So let's focus on that 76 point something. Now we got 80, which is good. I'm going to go a little abrupt from that to 190. Now we got zero point 0.6 of a volt and 197.93. So how is this computer? Computer is reading. Communication to the fuel pump module is good. The problem we have a stuck control for the fuel pump relay right here. So this is at the end drawing a lot of amperage because it's always on and it's damaging the fuel pumps. And most likely, the reason why he's losing communication with the fuel pump module is not because the ECM is bad, it's because that constant power is overheating the pump when it's not supposed to be on. So, because realistically, the way this is, let's actually do something. Let me take the ignition off. All right, as long as it's no ignition, that is off. Hmm. Ignition on. So is that off? Is that bad or not? That now makes me think, do we have any problems in here? Because yes, I mean, ignition on, that fuel pump should stay on, right? So I'm gonna have to read a little more and this now because I thought it was like just constantly on. Well, which it is. So if we set the ignition on this vehicle, that pump will be on. Ignition on, ignition off, relay is off. We lost the scanner communication. I just see that. The 5-bar reference is still on. Now it's off. You see how the computer now went to sleep. Hopefully you guys catched up. Were able to see that on the video. So yeah, the computer goes to sleep. Again, if I turn the ignition on, as soon as I do that, the fuel pump stays on with no RPM signal or anything, which I don't consider is good. Ignition off. Again, watch the 5-bar reference. I'm just starting to lose the communication. I can now see engine coolant temperature is starting to go down. So the computer is going to sleep, and now it went completely to sleep. You see the 5 volts went completely down. Huh. Yeah, this is sometimes it's a little hard without having the entire vehicle to see how the reaction of this should be. I will expect to have a pump like this waiting a cam sensor or cam or crank sensor signal in order to be on. So I'm going to read more information about this to see what are we missing in here because for what I can see, this computer is working good. The only thing that I suspect is that fuel pump relay is staying on as soon as you just set the ignition on, which I don't think it should be like that. This is not like a fuel transfer pump. Like I said, this is the main fuel injection pump module. And because let me just think about this. Because this has a fuel pump control module. So when you power up the vehicle, it should come on. If this relay is not on, the fuel pump module will be off because there is no other power going to it. If we go into this, we can see that in here, right? So we got the data link connector in pins 1 and 2, low idle select, fuel shut-off signal, which is obviously as it says, we got a ground, fuel pump relay output, fuel injection pump sync signal. That is the one. So we got a cam. This has got to be the sync signal has to be coming from either the cam or the crank. But now I have to read more, and that's the problem when you have these old vehicles, because these old vehicles are hard to find a complete theory of operation. So I'm going to have to do a little more homework myself and find out if this is a proper behavior or it's not. Because yes, that is on. That is an on signal for the fuel pump module, because otherwise we will have no, this will be off. Hmm. Computer is working perfectly. I can see communication. I can see the firewall reference is staying on for a little bit, and then the computer goes to sleep. Again, just watching here, you will be able to see that 4.97, and then now, boom, it went down to sleep. The computer lost data on the scanner, so that's working good. Yeah, this order module, it has no constant battery feed, and then an ignition like a like a computer. Like say, use this computer will always have power to keep memory alive and all that stuff. And then it will have an ignition on that will be the one waking up the module to, okay, we're ready to start a car. Come on, you know? But that is not the case on the fuel pump module. The fuel pump module is controlled directly by the computer. So this will not be on until, because this is what I need to think on. So what I want to check, because obviously we got the signal on pin 36. That's exactly what we are seeing, and that's why that power is on. That power is not on until we put the ignition on, which at the same time is the one is telling the computer to power up. All right, yeah, guys. Just to not make this video too long, let me try to find the theory of operation and make sure that if I do any recommendations on this computer, it's because it's definitely necessary, because I'm not sure if this is a normal behavior or not. All right, guys, I want to follow up a little more on the testing that I want to share with you of what I do here and also for the customer. Um, Looking at the communications, I got more files in here. I'm not going to turn the screen recording on. I'm not sure if I want to or not. I think it's not necessary. So I download a few tests. Let's say, no response from the ECM. We can see here that we got, the same powers and grounds, which is good. This is a nice diagram that shows you which ones are the powers and grounds. So we can see fuse ignition in pin 5, ground in 30, fuel injection pump relay control in 36, CCD bus plus and negative on 40 and 41, fuse power on 48, ground on 49, and another power on 50. So I went ahead and connect the CCD bus because as far as, again, this is hard to find information, even though Identifix has a lot, and I have created a lot of bookmarks. So I went over to Identifix, and you can have the Dutch OEM information, and I have going into, as you can see, everything that is in red in here is all the files that I have visited, and I have put a lot of bookmarks. So right now everything that I want to check is in there. So no CCD messages received from the ECM. This is a test, again, the same test that I was there for. And these are the network. We can see the DLC is part of it. And pins 3 and 11, which I have connected to. I suspect that that communication is for when you're using the original scanner like the DRB, which they refer a lot of that in here. And then pins 7 and 6 are for aftermarket. That's all I can see, or maybe programming. So it's hard to say because there is not much talking about that. All it says is with the DRB select body, then type cluster, you have bus test will automatically run and blah blah blah, a whole bunch of tests that check 10 ohm resistance and so on, and that is to do in the vehicle. Let me just see what else I want to check in here. Idle validation, it has IBS sensors, so it's some things that we need to check on the actual vehicle. I cannot do the checks in here. It will throw a fault if it's a fuel pump circuit problem, and it will It refers about the fuel relay here. Fuel injection control relay is nice. It tells you what the pins are and everything, but then going down into testers, all they're doing is showing you how to test the resistance of the relay itself. It's not any information that tells me if the ignition on will have that on all the time, which I would suspect it is, because right now this is ignition on, not key on. So, sorry, it is key on, sorry. It's not just with the battery on. So right now I have battery connected like normal in the car. The computer will go to sleep, and we see that before. And now go to sleep, and then I lost communication with the scanner and so on, right? So I'm going to establish this back on, but as soon as I turn the ignition on, it's sending power to that relay to activate the fuel pump module. I can see the scanner is reading properly because it says no communication between the ECM controller and the injection pump module. So this is good. All that information is good. No message from transmission control. This vehicle has also a JTAG or JTAG PCM on the passenger side. It's a 3-connector PCM that is for transmission, air conditioning, and I think power generation, generator control, and so on, but nothing to do with the engine. All right, so I did check a lot information, computer data lines. I went to system diagnostic trouble codes, no response condition from the ECM, just the powers and grounds. I was looking at the camshaft, the crankshaft position. All refers as the crankshaft position is a 35 teeth with a gap. The camshaft, it says, is just for TD, cylinder 1 position. And we can see right here the crankshaft position. So in case no engine speeder, well, that's the fault. Theory of operation, the CMP, crankshaft position, is used to verify the position of the cylinder 1 during engine operation, right? So yeah, that's in the crankshaft position. They don't say much. Let me just find it right here. Theory of operation, the crankshaft provides engine speed and position information to the ECM. The sensor must be powered up. Well, we know that, and that's what it says. The tone wheel has 35 teeth and a gap where 36 tooth will be in place. So it's missing 1 teeth. All right, so and that is again the diagram they show in there. So yes, as you can see, I've been doing my homework on all this. I could not, there is another, I could not find the information. There is a PCM operating modes, which I found that I'm okay, finally I have found, no, it's not. So and here it says ignition switch on. With ignition switch on, the following actions occur. The PCM and ECM receive an ignition sense input. They power up. Battery voltage is supplied through the battery voltage input. The way to start: water and fuel, check engine, check gauges, and transmission temperature. Auto transmissions only. Lamps are turned on by the PCM, ECM, or BCM for at least 2 seconds. As a bulb test, this is done by direct wire or through the bus to the smart cluster. The ECM monitors the intake temperature signal. If the intake temperature is below a predetermined temperature, the ECM will start the air intake heater preheat cycle. The ECM will energize the intake preheaters by grounding the air intake heater relays. The ECM will turn the wait to start lamp on until the preheat cycle is over. If the ECM receives a crank signal before the preheat is over, the preheat cycle will be aborted. The ECM will request the water and fuel lamp on if a signal is received from the water and fuel sensor. And no start the car, or you should not run it, but again, that's because it's water there, not because you cannot start. But yeah, it doesn't make it doesn't give me any information about that fuel relay or not. So the things that I want to share, this is one thing I want to share with you, is the test that I want to do as far as 5-volt reference, because this is something I should have checked in the video, so you can see and he can see the full test. So right now I'm connected in pins 31 and 32, which if we go here, ECM pinouts are probably better. So 31 and 32 right here. So 31 accelerator position sensor supply and 32 accelerator position sensor ground. So we can see that we got a 5 volts. So, and that is again These two cables is in the 1, 2, 3, 4 row, pin 31 and 32. I want to go to the next one so we can see all this 5 volts working. We're going to have pins 10 and 11. So 11 is a ground. I'm going to take the ground off from here. So 11, 1 to 11 should be here. If that sensor ground is good, now we got 5 volts, so that sensor ground is good. And then the 5 volts should be pin 10. So I'm going to move this one to the pin 10. And we got 5 volts. So we know that all the tests and everything that I'm performing here are perfect. We already checked pins 3 and 4, but I'm going to do it again just for the sake of the video. So pin 4 is ground. So if I plug this in here and that ground is good, which I know it is, we now have the 5 volt reference because, I mean, we are providing the ground. So we're going to move into pin 3, and that should be the last 5 volts, and we got the 5 volts. All 5 volts are working. The computer is coming on. I got communication. I don't see nothing wrong with this computer. Nothing that will prevent the vehicle to start. Nothing that will damage the pump, if that is normal. All right, guys, I found the information. Finally, I was able to. It's actually in the name of fuel injection pump controller supply voltage too low. And this is for powertrain diesel. All right, because I found one for the gasoline, but it says powertrain gas. Obviously, it's not the correct one. All right, so let's look into this. So this is the fuel injection pump module connector. We have pin 7 as being the relay output. If we scroll down in here, it says when monitor ignition on. Fuel injection pump controller supply voltage low. Set condition engine speed 100 RPMs or greater than 100 RPMs. Theory of operation. This test is performed in the engine control module ECM. The ECM monitors 2 battery voltages measured by the fuel pump's battery voltage sensor. The voltages are, so this is the way it knows if it's low or not. So as measured by the fuel pump's battery voltage sensor, so we have the battery voltage sensor, battery voltage as measured at the fuel pump when the fuel delivery valve solenoid is not energized, and the battery voltage as measured at the fuel pump when the fuel delivery valve solenoid is energized. So it's checking to see if the battery voltage is good, and then it will set up a fault based on that. So definitely the fuel pump will delivery pump, let me just read that. So the fuel delivery valve draws a significant amount of current. If the resistance is high in the harness supply current to and from the fuel pump, the battery voltage will drop significantly. That's a hard word for, so significantly. All right, so just don't laugh too much of me trying to say that word. When the fuel delivery valve is not energized, a DTC is stored. So that's a test. But what I want, and this is what I want you to read. This is a full, bunch of tests in here using a voltmeter to measure the battery voltage across the battery. Well, we don't care about that one. Right here, disconnect the fuel pump, the fuel injection pump module connector. Key on. All right, so key on right there is that is exactly what I was looking for. So just with the key on right here, using a voltmeter, measure the fuel injection pump relay output circuit. Is the voltage above 8 volts? Yes, that's fine. That's all they want. It is fine. Using a 12 volt test light, check the fuel injection pump ground circuit to be plus. All right, so using in the same connector, you got the ground. Is the test light illuminated and bright? Yes. Okay, well then, at this time, the conditions required to set this trouble code is not set present. Test is complete. That is exactly what I was looking for. So guys, this is 100% a normal behavior. Francis, I cannot find anything wrong with this computer. Not for what your concerns are. The way this is, this truck will run. Even if you unplug the fuel pump module, let me turn this off because the light is in my face. So if you unplug the fuel pump module on this system and you provide that ground, let me go back to that same
um, diagram that we have here. If you have this connector, or a way to get yourself a connector, I can get a part number, but if you look online, you can find this connector. But if you provide a power and ground to that fuel pump module, the car will start in idle. It has to start in idle. I don't care if you unplug it from the computer. Yes, you might set faults about not having communication with the fuel pump module. This truck will run 100%. So yes, if you don't want to do that test, because realistically, I mean, all you really want to do is ignition on, check pin 7, relay output, and pin 6. Do you have powers and ground? That truck needs to run. Otherwise, you have a problem with the fuel pump. That's it. There is nothing else. You can, what I'm trying to tell with this is, like, even if you disconnect that harness and you put your own power and ground in there, that truck needs to run. You have to have obviously communication with the ECM. We do have communication with ECM. I have 5-volt reference. Everything is good. So make sure, guys and friends, is do these tests, and that's why I've been, taking the time to explain this further. Like, you need to go over to that connector, to this connector behind, and check your powers, check your grounds, and check your 5-volt reference. Check the 3 5-volt reference, as I mentioned in here, pins 3 and 4, pins 10 and 11, and pins 32 and 33, or 31 and 32. If you have all those powers and grounds and 5-volt references, you got no communication, well, something is maybe in the harness. Check the wiring, the communication lines all the way to the DLC. That will be, again, just scroll back in the video where I talk about the communication lines, and that's all you need to do. But this computer is talking, this computer is working good. All right, guys, another 14-15 minutes. I hope that you understand that I'm just not showing you how to do a bench test on this computer. It's how to test it in your truck. You have problems that you think your computer is bad, I need you to run this test too. Use a multimeter like this, check powers and grounds, use a test light. This is a test light. You can use this test light to check powers and grounds on this. If you're checking the grounds, then you're going to connect one end of the test light to battery positive, and then you're going to use a pin like the one I have showed before in multiple of my videos like this. I can put that into this test light right here, right? So if this is me testing for powers and grounds, I can connect this here, and then I can go over to grounds, and that light should need to light up very nice and brightly. When you're checking for powers, don't do this test on the 5-volt reference. On the 5-volt reference, you just want to use a multimeter. For the main powers and ground, you want to use a test light. All right, guys, I hope all this is helpful. See you next time. Bye-bye.